welcome to Two Projects. In this video, we are going to explain the project Light Repository Blockchain System with Multisecret Sharing for Industrial Big Data. Introduction. This project aims to make industrial data safer and more accessible by using a light repository blockchain system with multi-secret sharing. Traditional data storage methods often rely on centralized servers, which pose significant security risks. If these servers are compromised, all stored data can be lost. This vulnerability is a major drawback of conventional data storage systems. To overcome the limitations of traditional data storage methods, this project introduces a novel approach that combines blockchain technology and Xiaomi secret sharing. Blockchain is like a digital ledger that records transactions securely and transparently. Instead of having all the data in one place, blockchain stores records as blocks of data, each with a unique code called a hash. These blocks are distributed across multiple computers or nodes, making it much harder for anyone to tamper with the data or compromise the entire system. Blockchain offers several advantages. First, it is decentralized, meaning the data isn't stored in one vulnerable location. Second, it enhances security because the data is stored in encrypted format that is very difficult to alter or hack. Third, it promotes transparency as all transactions are recorded and visible to authorized users. Fourth, it ensures data immutability, meaning once something is recorded in the blockchain, it can't be easily changed. Finally, it is resilient to failures because even if some nodes go down, others continue to maintain the data. Objective of the project. So, as I mentioned earlier, the project aims to enhance the security of industrial big data through the development of a specialized light repository blockchain system incorporating multi-secret sharing. This objective is driven by the need to safeguard critical industrial data. And to address the risks associated with centralized data storage, the project seeks to distribute data across multiple nodes within a blockchain network. By doing so, it aims to reduce the exposure to data loss in case of a security breach. And the project's third objective involves optimizing data management in industrial settings. This will be achieved through the segmentation of data into blocks, reducing storage requirements and computational burdens. Additionally, Xiaomi's secret sharing will be implemented to enhance data security and integrity. Requirements needed to execute this project are hardware requirements: processor of i5 and above, RAM of 8GB and above, ROM of 25GB and above. Software requirements needed are Node.js, Python 3.7.0 and Visual Studio Community version. To execute this project, we have designed few modules. The first module is Enter Block Data. In this module, users input the data they want to store in a block. This could be any piece of information or data relevant to their industrial application. The second module is Share Blocks. After entering the block data, this module facilitates the process of splitting the data into shares using Xiaomi's secret sharing. These shares are then distributed between multiple nodes in the blockchain network for enhanced data security. The third module is Retrieve and Reconstruct Block. This module serves as a data retrieval and reconstruction tool. Users can enter the block number they wish to retrieve and the application collects the required shares from the blockchain nodes. It then applies the Xiaomi secret sharing technique to reconstruct the original block data, making it accessible once again. And the last module is Storage Graph. So the Storage Graph module provides a graphical representation of the project's data storage approach. It illustrates the comparison between traditional storage, where full transactions are stored, and the proposed method which stores only individual blocks. This visual representation highlights the reduced storage requirements achieved through the project's approach. Blockchain integration. So, by using blockchain technology, data security and availability are significantly improved. In traditional centralized systems, data is stored on a single server, creating a single point of failure. However, in a blockchain network, data is distributed across multiple nodes. This means that even if one node fails or is compromised, the data remains accessible from other nodes, ensuring continuous availability and eliminating the risk of data loss. And in a blockchain network, nodes work together to validate transactions using cryptographic hash codes. Before adding a new transaction to the ledger, every node in the network checks the integrity of the previous transactions. This rigorous verification process enhances the trustworthiness of data within the blockchain, making it highly reliable and tamper resistant. The project uses blockchain to split data into blocks. This approach reduces the amount of storage space and computational power required. By dividing data into manageable blocks, the project makes data management more efficient and cost effective while still benefiting from the security features of blockchain. And Shamir's secret sharing, a cryptographic technique, is a key component of this project. It leverages the distributed nature of blockchain. Shamir's secret sharing is a cryptographic technique that splits a confidential secret into multiple shares, which are then distributed among participants. To reconstruct the original secret, a predefined number of shares, the threshold, is required. It operates based on polynomial interpolation, with each share representing a point on the polynomial. This process enhances data confidentiality and integrity, making it extremely difficult for any single node to compromise the complete dataset. The distributed nature of blockchain further reinforces the security provided by Shamir's secret sharing. Execution of the project. To execute this project, first we need to open the code folder which contains the project source code files. So to implement this project, we have developed two blockchain nodes and a client application. The client application is used to send Shamir secrets to the blockchain nodes for secure storage. So these are the two node folders. I'm opening the node 1 folder. So here we can see Python main code files and a run.bat file. So by double clicking on it, we can initialize the node 1. So I'm double clicking on it. So here we can see blockchain node 1 started and waiting for incoming connections. So the node 1 has been started. Now minimize this. Now similarly double click on run.bat file in node 2 folder. So here we can see blockchain node 2 started and waiting for incoming connections. Now minimize this, and here we can see Python files and a run.bat file to open the client application. So instead of executing the project through command line interface, we have created Windows bat files to execute the project. Now double click on it. So this graphical user interface will be opened. With this, we are interacting with the program. We have used Tkinter library to create this graphical user interface. So here we can see our input box where we have to provide the data to be secured. So I'm giving it as 1, 2, 3, 4, and now click on share blocks button. So the given data will be stored between two nodes as Shamir's secret. So in the text area we can see the provided block data is transformed into multiple share values of a specific length. So these are the values. And these numerical shares are then distributed between two nodes for enhanced security. And here we can see node 1 received blockchain transaction, node 2 received blockchain transaction. Now in the console view, so we can observe that both nodes has received their respective parts of the shared data. And we can see the current hash value of block 0, this is the current hash, has become the previous hash of the current block, that is block number 1. Indicating a successful verification in the blockchain system. And instead of the initial input, we see a representation of Shamir's secret, which is super secure and not understandable by anyone. To get back the original data, just enter the block number. The application collects the shares from all nodes and brings the original information back together. So we'll try that. Open the application. So I'm giving the block number as 1. And now click on Retrieve and Reconstruct block button. So we can see that we have collected shares from both nodes, enabling us to put together the original data. This works for any data we want to store as blocks in the blockchain. Just enter the block number and we can easily get back the original information. Now click on Storage Graph button. So this graph displays two things. So storage methods on x-axis and storage size on y-axis. In usual storage, where we keep complete transactions, the size is huge. But in our new method, we only store individual blocks, making storage much smaller. Now minimize this. So the conclusion here is, the project represents a significant advancement in industrial data security. By implementing both blockchain and Shamir secret sharing, it has created a robust system that safeguards sensitive data, making it much more resistant to breaches and unauthorized access. The project ensures data remains accessible even in situations where some nodes are compromised. This is because of the decentralized storage approach, which means data is distributed across multiple locations. So even if one node is affected, others retain the data, ensuring uninterrupted data availability. Data splitting and Shamir secret sharing reduce the project's storage and computational requirements. This efficient data management makes it cost-effective and practical for industrial applications, allowing businesses to handle data more effectively. The project prioritizes user-friendliness by designing simple-to-use blockchain nodes and a client application. This ease of use ensures that even non-technical users can effectively manage and secure their industrial data. So the project serves as a strong example of how blockchain technology in conjunction with innovative data handling techniques like Shamir secret sharing can significantly enhance industrial data security. It demonstrates the promise of these technologies in protecting vital industrial information.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.